Hey, everybody. Welcome to the May edition of the Leptos Meetup. I don't know that we can call it a Leptos monthly meetup anymore, Greg. I don't even know that we can call it a Leptos quarterly meetup, but it's some kind of a meetup and it's on some
Yeah.
kind of a at least semi-annual schedule at this point. So,
Yeah.
um, yeah. So, yeah, as everybody can probably see with me here, I've got Greg, we got Ben on standby. I think he's running a new Linux distro and getting stuff set up on his end still. Told us to go ahead and get started, but yeah, we've got a couple of big updates for you, and I'll go ahead and pass it over to Greg. But before I do that, don't forget to join us on the Discord server if you haven't already, like the YouTube channel. And on this meetup, we're going to be covering primarily two topics: 0.8. And I don't know where we are. I don't know if we're in a beta now or if this is a release candidate. Greg, I'll let you cover
Yeah.
that,
Yeah.
and then Greg's got a server functions WebSockets demo that we're going to cover. So I'll just go ahead and pass it off to you, Greg. Um, and I'll monitor the chat for questions. So if anybody has questions, please feel free to ask. I'll be more than happy to help.
Awesome. Thanks, Luke, for running again. Hi, everybody, whether you're watching it live right now or catching up with the video later. Nice to see you all. I know it's been a little while since we had one of these, largely because of me, I think. The winter, early spring is a pretty busy time for me. And, we went and Ben and I were both at Rust Nation UK. I gave a talk there, which was a lot of fun, but it kind of took a lot out of me and working on the 0.8 release stuff. And I kind of felt like for a while there wasn't a lot of news to share. And so, yeah, I just wanted to say, I think we'll start out. I'll say a little bit about what's actually in the 0.8 release, just so people know. Take a look at the release notes. And then I have a demo of some of the WebSocket stuff because there's a very basic demo in the release notes, but it's really basic to the point of, not being that helpful. So I want to flesh something out a little bit and show like what you might actually want to do with this. And I know if Ben can get through his video driver kind of issues, I know he had some demos he wanted to show. He's been working slowly on kind of rewriting and updating Cargo Leptos, and we've both been kind of bouncing around some different ideas for like UI there. So I think he has some stuff that he wants to show off if he can join us. Yeah, so I'm gonna go ahead and share this. Allow. There we go. Yep. So I'm going to start sharing, and I just thought we would go onto the repo and look at the release notes. So we are on 0.8.2 now. We went through 0.8.0 with all the alphas and betas and stuff we did release. And just for a little background, right? Like anyone who's been following the framework for a little while knows like 0.7 was a really huge project, kind of rewrote everything, made a lot of breaking changes. And we had a pretty long alpha beta, like 4 months worth of pre-releases for that. But obviously when you have a big set of changes like that, you kind of just know there are going to be things that break or that need to be updated or that bugs that you didn't anticipate that are going to require breaking changes. So I kind of always planned on doing a 0.8 release anyway. And then we had some changes to server functions and things that people wanted to make. So we ended up delaying a little bit longer just to get in the variety of different changes. So I thought I would just say a few words about the changes here in 0.8. So the first one, Axum 0.8 support. I think this is probably big enough. I'll kick it up one more for people. So Axum 0.8 support, just as far as the way that versioning works with like Cargo Toml, when you re-export parts of a dependency like Leptos Axum does with Axum, if they bump a major version, like from their 0.7 to 0.8, we need to do from a 0.7 to a 0.8 in Leptos Axum anyway. So we try to kind of keep all of our packages on more or less the same versions just for the sake of minimizing confusion. So we had to wait to include that, but that's a nice little bump. Good to be able to migrate over to that. Zach contributed some really big improvements to compile times when using the erase components feature, which one of the big changes in 0.7 was having this like statically typed view tree, but that added a lot of compile time in some situations. And so this makes that better. This is just done by default now in Cargo Leptos. So that got turned on as the default setting rather than you having to opt into it to make it a lot easier. And so that should improve compile times a lot. It has also surfaced a bunch of bugs. That's why we're on 0.8.2, not 0.0, because there are a bunch of small bugs that came up just from activating that everywhere. but should bring the compile times back down to close to 0.6 what they were. There is an islands routing feature that was part of the talk I did at Rust Nation. So if you want to see more about that, you can maybe check out that talk. It's on YouTube. But building that in, basically what this does is it lets you use islands, like the islands mode that we have, where you don't ship WebAssembly code for most of the application, and then you opt in with like these small islands of interactivity. But then it added kind of client-side routing so that it feels like you're using like a fully hydrated app, just like any other, but you're actually only shipping parts of it. And maybe I'll do some more about that in a future meetup or something, so we can go through it in a little more detail. And then there were some changes to server functions. So a couple of the server function changes. One, people have been continuing working on improving the error handling, letting you use more different types of errors. So it doesn't just have to be the one server function error type, but you can create your own custom error type and then implement a trait on it, and you can use that for errors. So thanks to everyone who's been working on that. One other small kind of change with local resources. In 0.7, there was this awkward thing where they returned a send wrapper, and you'd have to do like as deref or dereference it or .take or stuff. So this will break some code if you're using local references, but it ends up making it a much better API. Like it just returns the plain type that's in it. So this is probably the one that has the most breaking changes for people, unless you're using some kind of custom server function errors already. Some improved stuff on actions, not huge. And then big shout out to Evan Almloff, who's one of the Dioxis maintainers, for contributing support for WebSockets, and then a couple other people made PRs kind of cleaning stuff up. So thanks to everybody who was involved in that. But that's kind of what I want to mostly talk about today. And Luke, feel free to pause me. Like if people ask questions on YouTube, and people on YouTube live, feel free to ask questions too. Like anything on 0.8 so far, I'm happy to talk about before we kind of dive into the demo. So maybe give a minute if anybody has any questions, and then we can kind of change gears.
Yeah, for sure. I'm monitoring the chat, so if I see something relevant, I'll jump in at an appropriate time.
Awesome. Yeah. So the WebSocket thing is great, right? There's always been this kind of back and forth. How can we support WebSockets in server functions? Because WebSockets take a little bit of ceremony to set up, but there are some things that you can really only do well with WebSockets, right? And it was kind of just a matter of waiting to find a good API for how that worked. And what we landed on was basically a server function that uses WebSockets, takes this protocol. This is one of the changes that made this 0.8, was sort of changing the way we think about input and output encodings to also add this protocol thing, right? So normally this is just like an HTTP request, but you can say, hey, this is going to be a WebSocket. And what that does is that it then automatically upgrades the server function call for you into a WebSocket connection. And then when you do that, you can specify how that's actually being encoded. So you can send binary messages that are like encoded with archive or whatever over the WebSocket. It doesn't just have to be JSON. And then what you get is you have a function, and the API is basically, it takes this type that's called box stream, which is a stream. If you haven't used a stream from like the Rust futures crate, stream is a trait that's almost like an async iterator. So a future, you call it, you wait, and it gives you the answer. A stream can give you a number of different values over time, and you kind of wait for each one. So the input is a stream of somethings, and then the output is another stream of somethings. And then here's this example. This one is really simple, but it could be useful just walking through to see what that actually does before we get into like the real example. So first we create a channel, right? And then we're going to spawn a new task. And if you think about it, right, when you call the server function, you want the server function to return relatively quickly. But because we're going to be sending messages over WebSocket, we kind of need to spawn a new longer running task. And so we use Tokyo, we spawn this task, and then we have this, async block for the task. And then inside here, you can see this is how streams work if you've never used them. The most basic way to get things out of them. If this were like a regular iterator, you would have a for loop. You have this while let some message equals input.next.await. And if you think about it, right, it's like input is our stream of messages coming in. So this is the stream of messages that the client is sending from the browser over the WebSocket to the server. And so input.next gives you a future that will resolve when the next message comes in. And so, if that's some, you go inside the loop, you do something. If that's none, it's going to break out of this loop, which means the task will be over, which means this will be torn down automatically. The WebSocket connection will end. And so we've spawned this task. But from the actual server function, what we do is we just immediately return the receiver half of the channel. So the channel here, right, has a transmitter and a receiver. We return the receiver and we give the transmitter over to this task. And then inside here, this is just an echo kind of message. So whenever we get a message coming in, these are all strings, right? And then whenever we get a message coming in, we're just going to send a message out where all that we did was we turned that string to uppercase and then we send it back, right? So it's just a silly little example, but it shows kind of what the API is for how you interact. So input is the stream of messages coming in. This receiver of the channel is the stream of messages we're sending back down. That's what we return. We return a stream of messages going back down. And then in between, we've spawned this task that lives for as long as the input stream. So as long as the input stream comes in, we have this task running that's going to send the uppercase version of the input back out. So that's kind of the dumb little demo version of how it would work. I want to show you a little bit better demo, something that you might actually want to build. And this is this little shopping list. So this is super basic, classic kind of shopping list demo example. Make it a little bigger for you. Here, instead of like those, let's put actual stuff. Apples, bananas, milk, bread. Oops, sorry, Brad. Show off the edit here. Bread. And then we can check stuff up. So when we get the milk, we just check it off, right? No big deal. We can delete stuff, right? So that's like fine. And the reason that we're doing this as part of a WebSocket demo is just if I open it in another client, right? What we're doing is we are using WebSocket to synchronize between multiple different users, right? So as a classic example, I'm probably going to go grocery shopping right after this. We put our groceries into the Apple Notes app. It is horrible at synchronizing. So half the time my wife has put stuff into the grocery list that I didn't see because it didn't actually come over the thing, right? Wish I had actually a working application, but any changes that we make here are just going to show up right in the other one, right? And so just to give a quick look, what's actually happening over the network here. So when I refresh the page, it has this messages WebSocket it connects to, and you see the hash at the end, right? This is a classic kind of server function looking thing. And then when I see these messages, so the first message up is this little message. It has this UUID. We'll just talk about that, and it says connect. It gets a message back down that says welcome and some JSON of a list of stuff. And then let's see if I mark this complete, I send another message up that says mark complete. If I delete this, we get another message up that says remove, right? So it's just everything I do is just sending a message over the WebSocket here. So let's look at the code, which is going to be the more interesting part here. So this is a totally normal, really, really simple kind of cargo Leptos template app with Axum. There's nothing interesting, right? This is the whole router. I don't have any WebSocket handlers or anything. This is all just being handled by Leptos routes and stuff. Totally normal, shell kind of function, putting my app right in here. Okay, and then this demo really, I'll give you one more size. Yeah, this demo is really actually showing off the combination of two features, which are stores and WebSockets. You can just use WebSockets without stores. You can use stores without WebSockets. But I think this kind of showcases one of the things that stores are really good for. One of the things that stores are really good for, right, which is you can take in messages. You can have almost like a state machine where you say, okay, how should I change this big thing of global state? And you still get fine-grained reactivity. So here's my shopping list struct. This is like the global state of this application, right? And you see I derived store on this. And there's going to be a keyed field. Each item is going to have an ID, which is a UUID, and that's going to be the unique key for it, right? So if you haven't seen stores before, some of this may be a little unusual, but check out the stuff in the book or in the stores example in the repository. So we've just got shopping list as a list of items. Each item has an ID, a label, and whether it's completed. And you saw, those are pretty obvious. That's what happened when I was showing things off. And then we have this enum of messages, right? And a message is going to be anything that can interact with this sort of state of the application. So any message that the client is going to send over to the server, basically. So that could be a message saying, hi, I'm connecting. Could be a message saying I'm disconnecting. Could be the message back from the server saying, hey, welcome. Here's the starting list of items. So you notice, right? Like if I refresh the page, I start with items. The message I got back from the server was this welcome message. It wasn't just a blank set. Obviously, you want to start with the items that are already on your list. You can obviously add an item. And to do that, you're going to give it an ID and a label. Makes sense. You can remove an item by ID. You can mark an item complete with the ID and whether it's complete or not. And then you can edit an item, giving it the new label, right? So that all is hopefully pretty straightforward. And think of the messages as like any action that you're going to do, anything the user does, because that's going to be logging on, disconnecting, getting the initial list, adding something, removing something, marking it complete, editing it. Any way the user interacts with it, we're just going to encode in these messages. And then we've got this little struct here that's going to help store what our local state is. I'll come back to that a little. Okay, and then I've got this state wrapper. And so think about, right, we had the state, which is our shopping list. And then we had this set of messages. And then we need some way of saying, well, how does a given message interact with my shopping list? And so we just have this little state, and apply local update is going to be a method to apply the message to the store. And if it's the connector, the disconnect message, we don't need to change anything. Us, the client, over to the server. If it's the welcome message, well, we're going to take the list that it gives us and just set the items to be that list. So again, if you haven't seen stores before, there's this kind of getter setter syntax for fields. So self.0, because that's it's wrapped, right? So we can implement methods on it. Items gives you the items field. .write takes out a write lock on it, and then we're just setting that to the list, right? So that's just saying overwrite whatever I've got here. It's going to be empty and give me the list. Likewise, if we add something, we're just going to take that same write lock on items. We're going to push an item into the store with the ID and the label and default it to not be complete when we add an item, obviously. If we remove something, we're going to, again, hit the items and just do, .retain, which is going to iterate over the whole list and keep anything that we tell it not to get rid of. So, if the item ID isn't the ID that we're removing, keep the item. Now, when we mark complete, right, again, this is pretty self-explanatory. We've got this find helper. So if we find the item, hit the item.completed, .write, and set it to whether it's completed or not. And then edit, if we find the item, update the label. And what's that find method? That's just self.items, read untracked. We don't want, if we're inside an effect or something, when we call this, we don't want it to rerun. So just doing untracked read here. And then this is just finding the position of that item. And then this @unkeyed is like a little store thing just to get us the store field at that index, right? So this stuff so far is all stores and so on. If you think about it, right, none of this so far has anything to do with WebSockets, really. You could actually choose to implement the whole state management for your application this way, right? Just by having a global state store and messages. You'll sometimes hear this kind of thing called the Elm architecture, which Elm is a programming language that's functional, that's the whole state. It's for front-end web UIs, and the whole state of your application is a state, and then a message, and then an update function, and that tells you how you update it. So it's called the Elm architecture sometimes. It's if you have like a computer science background, it might look to you like a pretty basic finite state machine, which it pretty much is. There's some input messages that make some changes to the state of the thing. So all of that so far, right? Like that is not WebSocket stuff. That's a nice thing you could do with stores as a nice way of just saying, here's my set of all the different kinds of interactions someone could have and how they're going to interact with the state of the application. And remember, this method was called apply local update, and we're going to see why that is. So then you've got the client, right? And what the client does, it just takes a new connection, returns this client struct, goodbye, just disconnects us. And then client.update is a method we're going to see called a bunch of times. So I want to talk a little about what it does. So client.update is going to, you give it a message, and it applies that message to the local store, and then it sends that update. And sending that update is going to be what sends it over the WebSocket. And then if we receive an update, right, this is receiving an update from the server. If it's the welcome message, we're just going to write that into the list. Otherwise, if it comes from a user who's not me, we're going to apply that to the store, right? If it comes from me, we already applied it to the store when we called update. All right, so let's look at the actual UI for a second, and then go back to the server function. So here's the UI, right? Just the app function. There's no router or anything in this. It was a one-page thing, right? So what we do is we create a channel, just like we did in the other example. We create this client thing. And then, if it's in hydrating mode, we're going to say, okay, if I leave this page, say goodbye, disconnect me. And then we just spawn a task. And we take this, we've given our little client struct this transmitter half. And we're just going to take the receiver half, right, which is going to be messages coming in from the server. And again, it's one of these while let loops. While let some message is messages.next. I'm going to log it out on the client. And then we're going to just apply this message by calling that client.received update method that was up above. So this is whenever we get something coming in from the server. And then in the actual UI, right, we've got our header, obviously. We've got the form. This is, when you submit, add a new item, it's going to get the item. It's going to call this client update using the add message, and then it's going to reset the form. And so you'll see in all of these parts of the UI, it won't be directly modifying the state. It's all going to go through that client, which is what is sending the WebSocket messages and what's updating the store. And you end up with this kind of nice, almost separation of concerns, right? Where the client knows how to apply a message. We don't need to directly mess with any state in the callback here, right? All that we do in the callback is dispatch this message that's then going to go through the system. And then we've just got the inputs here, right? And then really simple, got a for loop that's going to iterate over the items. The key is going to be the IDs. We're going to have an item editor for each line, and then the item editor takes the client and it takes that item. We've got a little local signal. Now this, you'll notice, this is just a plain signal, right? Like whether I, as any individual user, am editing a particular item doesn't need to be shared globally through this WebSocket. So that's just a regular signal. And then it's just got the checkbox, right, which is using completed, right? All this stuff is totally basic. It's just using the store. It's as if I'm interacting with local UI stuff, which I am. And then when I change something, right, again, I'm going to dispatch a message marking it complete. This is the checkbox for whether it's complete or not. The label here just has the label. The input has, again, whenever I change, I'm going to update the client by sending an edit message. And then remove, when I click remove, it's going to send the remove message, right? So all of that is pretty simple. It's like the UI here doesn't actually know anything about the idea of a WebSocket. It just knows about these update kind of messages. So this is something you could develop totally locally, and then you could add this kind of WebSocket sync engine later if you wanted to, right? Because you've structured the app this way. And then let's just rewind back up to the actual server function and see what it's doing. So here's the server function. And just like the one in that initial mini demo in the release notes, right? It takes input, which is a boxed stream. In this case, it's this message with user, which is just a user ID and a message. And then it returns message with user, right? And I think that there's a way to not pass around the user so much. This was just I spent a couple hours messing around making the demo, right? But this was so that I don't get into an infinite loop where or not an infinite loop, but like doing the work twice, where if I send a message, if I edit something, it sends a message to the server that I edited something. And then if that sends a message back to me and then that edits again, right? Like you just get into a bit of a loop. I think that it's actually not totally necessary because of some of what I'm about to say. But anyway, so we've got this server state, which is the same thing as our state. It just has a function to give us whatever the initial items are when somebody logs in, and then an apply local update thing. This was just me kind of messing around. I needed some way of dealing with, I implemented some methods on a wrapper for a store. And so I had to deal with the ownership and stuff. It's not super important, right? But I wanted to be able to use that same apply local update method so that I only had to write all the logic for how you modify the store once. And then what I've got here is, we've got one shopping list. So this is this demo application. There is one global shopping list. Anyone can open up the app and edit it. Obviously, if you're doing something real, you would have at this point some kind of a database, or you would have multiple different users and auth, and everything would be right in here. And if you think about it, right, you could throw auth in here, right, because this is an async function. It needs to return this box stream type of the messages going back down, but it doesn't need to return that right away. So I could go in here and be like, okay, first I'm gonna authorize the user, authenticate the user, and get the initial data from the database, right? Before I actually returned the stream of the messages. That would be perfectly fine to do, right? Because I can just .await something. So we've got the one global shopping list, and then I've got this, hash map of users and the sender for each user. And this is actually kind of important, right? Because this is how we're going to broadcast messages. That a message that comes in from one user is going to go out to all users. So we need to store some way of sending messages to each user in here. And this is a fairly stupid way of doing it. You could do dash map or something that's probably better if you have real scale, but whatever. And then just like we spawned that task before, we're going to spawn a task. So whenever we get an input message from this particular user, whenever a message comes in from this particular user, if it's an error, I'm just going to log it out. And then if it's okay, it's the user and the message. If it's the connect message, then we're going to take the transmitter that we created for this user. We're going to send our welcome message with the initial items. And then we're going to store this user's transmitter in our map of users so that we can send messages to this user anytime, right? So in other words, here's our channel. What we're returning is this all the way at the bottom. So this is the messages going back out to this user. So to send a message to the user, we send a message here. And so, you notice I just put some here and then take it out and unwrap it. The assumption here is that if I've written the program correctly, we're only going to get a connect message once per user. So I can just take this. And then we store it in the map. So when another user sends a message, we can send it through this through this sender rather. If the user is disconnecting, we're just going to remove their sender from the map. And then any other message, anything that's not the connect or disconnect, we're going to log out what the message was. We're going to apply it to our global shopping list using, again, this same method that we has all the logic is shared with the front end, which is nice. So we only had to write once what happens when you change this stuff. We're going to apply the local update, and then we're going to go through all the users, and we're going to send a message to each of the users. And if that fails, we're just going to remove this user is all that this is doing. But so we basically rebroadcast all the messages. This obviously involves cloning the message, whatever, but we're going to send it out through all of the streams. So imagine there are 10 windows open all on this shopping list. If one user sends it in, it sends it out through all the other 9 users. And the reason I was saying I might not need to have the message with user and so many checks, we actually check here and we don't send things back to this user. I realized like halfway through doing the demo, and so now it's actually just checked in 2 places, so it's fine. But basically what happens, right, is each one of these tasks is spawned when a particular user connects. So inside this, we actually always know who the user is who is sending us a message. So they don't actually need to send who they are, even though I wrote it that way, because there's only one user who's connected. Each task here, each loop represents a single connection to a single device or whatever. Yeah, and that's basically it. So we just rebroadcast this, and then obviously when somebody sends a message, it comes in, and then that gets applied to the UI for all the other users. And because the last thing I'll just say is because this was done with, with stores, it really is fine-grained reactivity. So like looking at this in the DOM inspector is a little silly because there are other things in the framework that would probably prevent it from, really causing misbehavior. But like, just to take a small example, if I go in here, right, when I check this on the other, if I go over to my other user, it's a little hard with the text so big, and I check this, right, the only thing that the DOM inspector is going to show changing on the other user is that this one class is toggled. And if you did, if you had effects that were reading from things or whatever, this really, because we're sending, it's making a change here, sending it as a message over the WebSocket, and then applying that message to the store, it doesn't affect all this state. And so, for example, say I'm editing this and I have this typed in and I have like some local UI state over here, and then I toggle this. Well, it doesn't affect any of the other state that I've already got. It's just that, once I change this, then we've got that over here. And say, I am editing apples and berries. And meanwhile, I can't actually click off of it without unsetting it, right? But these things can sort of overlap, right? And because we're sending these messages and because it's set up relatively kind of fault tolerantly, you can have multiple people editing things and it will sort of find its way. This is not a real, what's called a CRDT, conflict-free replicated data type. If 2 people send messages at the same time and they each create a new thing, they might end up in a different order, right? It's not trying to synchronize the order of things or whatever. There are data types that you can use that do that. This doesn't do that. But yeah, it's a pretty basic little demo. So I wanted to throw, for anyone who is online right now, if you go to leptosshopping.fly.dev, this is running live. Be nice that I'm not moderating this thing. But if you go in here, you can log in from your own devices or from your phone or whatever. This is actually running live. And you should see we can all sort of collaboratively be putting stuff in here. And there are a bunch of users, right, watching the stream, typing stuff in, and then it changes on all the devices, right? So that's fun. So yeah, that's basically the demo of the server function WebSocket stuff. We have any questions, thoughts?
Yeah, we do. We have a few questions actually, so I'll just take them in order.
Yeah.
So Spencer asks, when does the input stream end when the client disconnects? How well does it handle unstable client connections?
Yeah, right. So I think that the answer is when the client disconnects. Basically, if you think about, this is just building on top of, I think it's GlueNet on the front end, and I think it's Tokyo Tungstenite on the back end for WebSocket libraries. And so the way that it is set up currently is that the input stream, you actually, by the way, I should say, in response to this here, just to be absolutely wacko, I'm going to drop a link to this branch. This is public. It's just in a branch that's not merged to main. There's the code right in the shopping list for it.
So we can check off the make example code public.
Yeah,
Pretty
exactly.
please.
Done. Beautiful. So the input stream ends when the actual input stream ends. Like, not to be stupid, right? But what we actually pass it is the boxed stream. And so the way that like the stream implementation on a I'm trying to see where I create the channel. It's going to be down here. So like this futures MPSC, right, unbounded channel, when this stream will end is when this transmitter is dropped. So if I drop this transmitter before, at some random point or whatever, or if I call this goodbye function, right, it's going to close the stream, and then that task on the server will also stop listening and will also tear down. So it's like when the WebSocket will disconnect when this drops. Is this resilient at all to unstable client connections? No, I don't know. I mean, I think I don't think that we've built anything in. I don't actually know that much about WebSockets, to be honest. So I don't know how they handle a spotty connection, whether that disconnects, whether this would have to be called again. We might even, I mean, you can experiment and let me know, right? It might be that you would get an error, right? Because the box stream type here on the user, right? Message here that's coming in when I get a message from the server is a result. So that this could be a message from the server, or it could be a server function error. So it may give you an error if you disconnect from the server because of your network connection or something. I genuinely don't know the answer to that. So it may be resilient. You may be able to reconnect, play around with it. I'm not sure how exactly it would just work out of the box.
Okay, cool. I'll actually jump to Spencer also asked this question. Maybe I missed something. How does the server function have all the client connections? Was it some global state variable? Is there any built-in way to do it if you have multiple server instances?
How does it have all the client connections? So the whole API here is like an abstraction based on streams. So when you see the TX RX, that's creating a channel. And so where I stored all these senders. So basically there are a bunch of Tokyo tasks, right? Each Tokyo task is listening for messages into a sender. And then basically, no, I'm sorry. So it's not the task that we spawn down here. The kind of what this server function, what this WebSocket protocol does is it takes the stream that you give it out and the stream that you give it in, and it kind of maps these into the WebSocket messages underneath. And so the server function, it's like the implementation here maintains the connection such that it calls this function. It's almost hard to describe. It calls this function, and all of the input messages coming in over the connection from the client get sent into this stream of input messages. And everything that you send into whatever stream you return here gets sent back to the server. So ultimately, these are all just tasks in the Tokyo runtime that your server's using that are all independently kind of maintaining these connections, if it makes sense. Then the way in the server function that I maintained this like rebroadcasting feature where we're sending the message out to all the different users was just really simply with this map here that has all the senders. And that's because you can clone senders. So I can have 1,000 copies of the handle that lets me send a message to a user. So any of the different server functions can do that. Is there any built-in way to do it if you have multiple server instances? I mean, I guess you'd have to send a message between the server instances, right? Like the servers would have to, one of the servers, if user A is connected to server A and user B is connected to server B, and the question is, how can user A and user B interact with each other if you have multiple server instances? I mean, server A and server B, if we're talking literal, maybe not physical servers, but multiple server binaries running, then you'd have to send a message between those, of course. And that's not built in, but that's a request you can make. If you're talking about multiple calls to the server function from different clients, these static variables that are inside the function, they're not exactly global because they're scoped to this. But if you put a static inside a function, it will be the same. This is the same hash map anytime the server calls this function. It doesn't create a new hash map because these are static variables, not let variables. It's as if these things were global variables. Maybe that's the answer to your question. So these things are only created once. So every user, every connection that calls this messages is getting these same things just because I implemented them as static variables. They basically are global variables shared between every call of the server function. Maybe that's what you meant by multiple server instances, not multiple actual servers, which is what I thought initially.
All right. Let's see. Francois Ferrari. I don't know if I pronounced that correctly. I apologize if I did. It sounds maybe French. My wife tells me don't ever speak French because my pronunciation is absolutely horrible. But I can speak German pretty well. Anyways, he asks, how secured is such WebSocket mechanism? Thinking about authentication, JWT, how to handle authentication, think about using Axum and already have authenticated your user.
That's a great question. I don't actually know. I can think of a number of different ways that you would handle that, right? If you think about, and somebody feel free to correct me in chat, right? If you think about, if you wanted to be really focused on the security of it, you could send the JWT with every WebSocket message, and when you receive a message, authenticate the user, make sure it's a legit message for them to be sending over that WebSocket connection. And you can do that, right? Because again, like this is all just in an async loop. So I said, it's an async function that spawns an async task. That's an async loop. So you can do async stuff really at any stage of this. So like I said, you can authenticate up here and see, can this user even connect? Are they even allowed to start up a WebSocket connection? Or should I return an error to even the notion of connecting to me with a WebSocket? Or you can authenticate something in here. That's kind of the same thing. Or you can authenticate something in here, right? So you could have the JWT or whatever as part of each WebSocket message, and sort of each time they send a message, validate it. And that there may be use cases where you really do want to do that, because maybe if it's a really long lasting session, somebody could have some credential revoked in the middle of it, right? You don't want to just authorize them once. That's reasonable. And I think it's likely the case that WebSockets are, like, I think there's a very strong guarantee, I think, that this task, this loop, is the WebSocket connection that the user making the request made. It isn't like crossed with some other user or some other connection, right? So I think if you just need to authenticate once or something and then be in the loop, that should also be fine. It's still gonna be the same user. But again, like maybe they've logged out something, right? So I think it's reasonable to do it. There's nothing built in for that. But I don't think you can access cookies when in the, I don't know if they send cookies with them. So maybe something like JWT would work. But again, somebody may know WebSockets better than I do. I don't really know them, which is why I was so happy to have this contribution, because now I can use them without actually having to understand them.
Okay. Let's see. We have a couple of comments here, but the next question would be from Erickson. You mentioned that you could implement auth logic in the server function. For the WebSockets, in this regard, there's a way to put auth logic in some kind of middleware to already receive auth user.
Right. Yeah, I would say take a look at the other auth examples. Like I don't think there's anything specific to this about the WebSocket server function protocol, right? Because basically between like up to, in the body of this function, you're just doing ordinary server function stuff. So you can look at like some of the examples using auth with server functions in general. You should be able to, on the Axum thing, for example, right? There's like there's a middleware. I forget how exactly it works. There's an example in the server functions Axum example in the repository of using middleware. There's another auth example in I think it's in projects now in the repository. But so you can use auth just like however you want. There's nothing baked into this.
All right. Okay, cool. I think that's all the questions for now. If anybody else has any questions, you have a couple minutes to put them in the chat.
Yeah, great. And somebody asked in our fake chat of the to-do list, like what's the benefit of WebSockets for this? And so just to say maybe a word about WebSockets in general, I kind of jumped into you can use WebSockets without actually saying what the point of that is. So just the main thing I would say is that a normal server functions until now have always just been implemented as a plain HTTP request so you send a request to the server and then the server sends a response. And when it's done, it's done. And you can do some streaming stuff with that, but the servers don't always behave the way you expect. And, you can kind of get messages over time. And we have examples of that. And it's, but you can't like have a long lasting connection. It's a hello, goodbye. And it's like you call the function and then it ends. And the advantage of a WebSocket is that it just stays alive for a long time. You can send multiple messages from the browser to the server, and you can send multiple messages from the server to the browser. And so people use WebSockets a lot for things like a chat application, right? Or things like synchronizing a shopping list like this, or synchronizing a to-do thing. It's usually most useful either for things where the server needs to send you a bunch of updates over time, or you need to send the server a bunch of updates over time, or where you're trying to synchronize between multiple users in that way, in like some kind of a long lasting session, game, collaborative editing, like anything like that is going to be over WebSockets. So it's nice. You could always use WebSockets. Like this doesn't let you do anything that you couldn't do before. You could just use a WebSocket library. You just had to pick a WebSocket library for the client and then pick a WebSocket library for the server and then deal with serializing the messages yourself. Like this just provides you a nice little abstraction over using WebSockets that just uses a Rust language feature, async streams, and then lets you write the business logic, and it handles the protocol of it all, just like with regular server functions, rather than having to deal with writing a REST API on the server and writing the fetching logic on the client. You just call the function and it kind of deals with the protocol for you. So that's kind of the idea of bringing this into server functions and why you might use WebSockets.
Yeah. So yeah, much easier to do things like I know you mentioned a couple of use cases, but to throw like a concrete example out there, anybody who's used like a Miro board or Confluence, which has like real-time collaborative editing, uses WebSockets. So I guess that'd be much easier now with this. So I think that's basically it. Unless anybody has any more questions. So Zach, I will go. Oh wait, hold on. Florian snuck a question in right here at the last, at the bottom of the night, for Greg, but I think it is. Yeah, we'll go ahead and we'll throw this one in. Sorry about that, Zach. We'll bring you in just a second. Okay, are there lots of breaking changes from 0.7 to 0.8? I'm using Leptos struct table, love it, but it's still on 0.7. I'm a bit of a Leptos newbie and wonder how much expertise is required for PR. Yay,
what a great question. The short answer is going to be there shouldn't be a lot to change. Is Zach actually ready to come on, or are we trying to kill a few minutes so he can be ready? Because I can give him.
I think
yeah.
I think he's ready.
Good. Good. So I gave
Yeah.
you the short answer. I won't do the really long answer. If we were trying to kill time for him to be ready, I would actually just clone the repo and see and like start changing it. 0.7 to 0.8 is intended to have very few breaking changes. There, you may be able to do just a straight update. There are things that have changed. One of the reasons it's a breaking change is that there are things that are semantic version breaking changes within internal APIs that don't really happen in user code. So libraries may encounter a little bit more of that. Then there are other things that are just nice ergonomic changes. So depending on what exactly they're using in Leptos struct table, it may be that there are some breaking changes or not. But you really should be able to clone the repo, change the Leptos dependency from 0.7 to 0.8, and then the compiler should hopefully do a pretty good job of guiding you through that. So yeah, I mean, that kind of an update is actually a pretty good first contribution to make, because it shouldn't be too hard. It's like going from 0.6 to 0.7 was huge. That was maybe like a 20 on a scale from 1 to 10 in terms of change. This should be like a 2. So yeah, try it out.
Cool. All right. Well, thank you so much, Greg.
Awesome.
Yep. Yeah. Awesome. Looks like we're good to go. So Zach, I'll go ahead and bring you up on stage now. Greg, I guess, are you gonna hang out backstage, or do you want to stay on the
Yeah,
stream, or how do you want to?
I'll hang out backstage and you can bring me on if you want at any point. For anyone who's been hanging out in the shopping list thing, I'm just going to kill that app right now so that I don't have to look at it and feel like I have to moderate a globally available real-time shopping list for content. But thanks for you know, putting stuff in there and having fun. And yeah, I'll hang out. And hi Zach, nice to see you.
Hey.
All right. Thanks, Greg. Hey Zach, so how's it going, man?
Not too bad, not too bad. So I have been working on something called Leptos Fetch, which sounds very similar to Leptos Query, and that's because it's the replacement for it since it became unmaintained after 0.6. It's not a carbon copy, so it's sort of been improved and augmented as part of my replication process, and it's now super stable and I think quite cool.
Awesome. And you're going to give us a demo today? Is that right?
It's a super quick one. Yeah, I haven't got much,
Sure.
but let me see if...
Share your screen, I'll bring it up.
Yep. Okay, I might not be able to do this now. It's going to quit.
Yeah, of course. Oh, and we've lost Zach. Maybe while Zach is rejoining, Ben, I'll bring you on if that's all right with you. Okay,
Sure.
I'll bring Ben on. All right, hey Ben. So
Hello.
While Zach's getting his environment sorted, I guess we can pivot to you.
Yeah, so it's good to see y'all again. I finally fixed my Linux issues by installing a Git version of OBS and making sure all the headers are in sync and installing another. Anyway, it was a pain. So I don't remember what this background was. I think it might be spaceship.
Looks like Star Wars. Honestly, it looks like I think it's like the Death Star, maybe.
Maybe. I mean, at
That's
this
what
point,
it looks like.
yeah. But on my end, right, I've got a few updates. Next week, for those of you who may not know, is Rust Week, which is a big Rust conference in the Netherlands. I will be there. We'll talk a little bit about Leptos, try to have a workshop, and I'll probably have some stickers. So if you're going to that, come find me. I think it's going to be fun. Besides Rust Week, as Greg mentioned, I have been working on an update to Cargo Leptos. The most interesting parts of it are now that we can run the server backend command and the lib command in parallel, which should, roughly half our compile time. and that the modular kind of plugin system I've kind of teased is underway. So if we want to do a little screen share, I have a very, very rough looking Ratatouille Tui app that I've been working on.
Oh, cool.
Let's see if I can make that work in Linux.
Florian says that Rust Week is sold out.
Well, well, if you've already
Good.
signed up, then
It's because you're going to be there, Ben. You sold it out.
Uh-oh. It's doing this. Oh, okay. So I think you can see, or at least we'll be able to see soon, my command prompt. Hopefully that's somewhat visible. The new app I'm calling it Leptos Build.
Can you increase the size?
Is that better?
Yeah, I think so.
Make it even bigger. So my thought is that instead of doing, cargo Leptos build or something like that, you would be able to do like Leptos build, which is kind of a neat thing. It does run and produce something. So I will run it here, and you can kind of see the very basics of a Ratatouille app, right? We've got multiple command prompts that can output commands in, a paned view or a tabbed view. So yeah, I mean, that's about as interesting as it gets right now. But my hope is that we can build this kind of TUI app in a way that will provide a better experience for our users. Besides that, as I said, we're doing plugins. So the idea being that, instead of just having the commands that we have, say Leptos build, Leptos serve, whatever, people can install plugins and do like native, I'll say, commands. So maybe there'd be like a Leptos bundle plugin or a Leptos, I don't know. I'm sure people will come up with ideas for that. And if you've paid some attention to that, we're all doing that with WIT, with WebAssembly modules. You can see some of the things that you'd have to implement if you were building a module. It's all very rough and very early, but I'm hoping to get it into a minimal viable product state in the next couple of weeks. So we'll see how that goes. So, yeah. Does anyone have any ideas for things I should put in here, or suggestions or questions? Feel free to ask.
All right. Yeah, I don't see anything, but anybody, if you want to ask anything or you have any suggestions, as Ben mentioned, put it in the chat. Ben will be hanging out backstage and he can jump back on and address those.
Yep. Sounds good.
Okay, cool. All right. So, Ben, I will take you off, and we will try Zach again, round two. If we can get this going this time.
Yeah, sorry about that. I had to restart Firefox.
All good, man. No worries. Okay, cool. So I'll put your screen up.
Cool.
There we go.
So yeah, this is the repo if anyone wants to check it out. There's one example in there, and then otherwise the README is pretty comprehensive. These links sum up quite a lot of the features, which I won't go into all of them today. But effectively, Leptos Fetch is its original ancestor is React Query, and it implements a lot of stuff in a similar way and inheriting from that. So I've got a super simple example. So you effectively provide a query client to your whole app. So this is the same as you're just providing it in the normal Leptos way to context. It's just got a little helper, a helper function that does that. And you can add in options and stuff. Here I'm overriding the default stale time of never to every 10 seconds. And what stale means is if your query is stale, the next time it's used by a resource or something, it will automatically refetch in the background while still showing the previous cached value. And then I've got DevTools enabled as well. So I've got my little DevTools component, which I'm adding to my root of the app, and it'll show a DevTools component which will show the state of your cache and all the queries you've got in there. So this is just going to be I'll show you the actual app quickly. It's literally just a tiny little blog post app. So I can select from my blogs which one should be active. It's going to load it and show it. And this is just the difference between suspense and transitions, how resources work, and testing that. And so you can check between the different blog posts, and how that works is I have a server function here, which I'm loading into my query client, which I'm getting from the context. And the way that Leptos fetch works is it's keys queries based on the type of the function. So it's actually just typing, is storing the cache key as the type ID of this API function. And then in this specific case, there's no key. So this query function always returns just one singular value. And then I've got a secondary query, which is actually getting the full blog post, and then that's actually keyed on an ID. And what's interesting here is that this API function takes a U16, but it's actually providing to the key function an option. So that's actually a nice quality of life improvement upon the resources you get there, where you can either provide an option U16 or a U16 in this key function, and it'll handle it internally for you to automatically manage that. And so in the old Leptos query, you would get out some custom object here, and you're sort of going against the grain of Leptos, and was one reason why it was quite difficult to port over. In this new version, it's much nicer that it just returns plain old Leptos resources, and it's super nice and simple. And yes, so then we get the DevTools up. So we get to see actually the state of everything, so of all the items in the cache. And I can see at the moment it's got, so yeah, 2 of the 3, or all 3 now. And it shows which one's actually being used by the resource, which these 2 aren't being used, they just happen to be in the cache. I can see this is stale, meaning it's been alive for more than 10 seconds, and that means the next time it actually gets activated, it's going to be refetched in the background, and then you can see it's going to go stale again. You can see all the items in the cache, so it just basically requires that each value in the cache implements debug. It doesn't require JSON. It doesn't require them to be JSON serializable or anything. In that example, I've actually got RKYV as the encoding from the back end to the front end, and it's using that rather than JSON. And so there's first-class support for using different backends. Invalidations, you can invalidate items in the cache, you can clear the cache, you can do a bunch of stuff. So yeah, there's a lot more to it, but that's probably sums up the most of it.
Awesome. Okay, cool. I'm gonna bring Ben on. There's a question for Ben. I'm gonna keep you on, Zach. All right, Ben. So you wanted to, yeah. Okay, and Greg as well. Cool. All right. So Ben, I'll pass it to you.
All righty. So I realized that we forgot to mention that one other of the nice things that Point 8 does is we've drastically decreased compile times for development. And we've got Zach actually to thank for that primarily, because he wrote and optimized our erase components mode that had been pretty buggy and had some limitations in the previous version, but now it seems to work pretty well. At this point, we've even automatically enabled erase components mode for development builds in Cargo Leptos itself. So if you're using Cargo Leptos, you should just experience this. If you're using trunk, we have instructions on how to enable it. But thank you, Zach, for doing that.
No worries.
Yeah. The question, let's see. So in the CLI, we'll be able to attach a debugger to debug the server-side code. As far as I understand the debugger and the way we run it, it's that could be built into it. I mean, Cargo Leptos build primarily exists to build the code and then to rebuild the code. But if there was an easy way for us to make it so that you can attach a debugger, that'd be a great PR. I don't really use a debugger that much, but yeah, we will certainly keep an eye on that.
Yeah, we have a question actually. I think this is aimed at Zach as well. Is the dev tools automatically stripped out of release builds, or do we have to manually conditionally include it in our apps?
Yeah, it'll get stripped out automatically. So it'll take up no binary size or show at all in release mode. There's an extra feature you can add to opt out of that and have it always show. But yeah, it won't show by default.
Cool.
That's awesome. I just wanted to say somebody asked me in like a question on the awesome Leptos repo or something in some context of like, oh, should I, what's a good replacement? Leptos query is not maintained. Should it be Leptos fetch? I know it's pretty new. And it was like, yes, use Leptos fetch. I mean, great, awesome work. And I'm so glad you got it updated and for 0.7, 0.8, whatever. And I would love to see people kind of like centralize on a few. I think it's the most comprehensive solution for global async state stuff with Leptos, period. If you have relatively simpler things that it's just going to be driven by the URL and you're using stuff from the router and a resource or whatever. But it's like once you start hitting the cases where, just using one resource is not cutting it for you, I feel like Leptos fetch now is probably the best solution. So I'm really glad that you like took on updating that. But I mean, all that revalidating stuff, the stale times and things like that's awesome. So yeah, people definitely go ahead and use it and try it out for anything that is even moderately complex, because I feel like if we have a few projects that people create and maintain well and then other people use, it's just going to improve. And that was like kind of how Leptos use became such a great thing, right? Is like people taking on themselves to get stuff up and running, and then I don't know, it can become like a cornerstone. So yeah, thanks Zach for your work, and thanks for getting annoyed enough at the compile times to put so much of your time. I always think it's funny, right, when it's like, my compile times have gotten so long that now I've spent hours of my time instead of waiting for the compiler fixing the problem. So thank you.
Yeah, with one project I had, I think got down up to 2 minutes to compile the server side, and that was what I had enough.
So bad.
It's I'll have to figure out how to smush together Leptos fetch and stores. I think those would work pretty well together.
Yeah, and people have asked a couple times too, like, how do I use resources with stores? And the answer is like, yes. Great question. Don't have an answer for you. Sorry. Having created the resource thing a few years ago and then created the store thing a few months ago, there just isn't an obvious answer. But yeah, because I think it'd be pretty powerful combination.
I'd also like to give a shout out to the company both Zach and I work for called IDverse. Zach built Leptos Fetch because we needed Leptos Fetch, I suppose. And we built it partially on company time. So they've been very supportive of us working on Leptos and Leptos related tooling and making it available to y'all. So thank you, IDverse.
That's awesome. Okay, well, it looks like there's no more questions. Let me pop over to Discord. Yeah, we're good to go. Oh, there's a question in Discord, but I think that's just a question in Discord. I don't think that's for the stream. So
Discord general chat live.
I know. Yeah. Man, that's a whole stream unto itself. Yeah. Okay, cool. Well, then I guess that's it. We can just wrap here.
Awesome.
I don't know when we're going to do this again. Do we have any idea, Greg and Ben, when you guys think you'll find time? Or
I could potentially return to the roughly monthly schedule that we've maintained before.
Yeah, yeah, sometime in early June or something. That would work for me.
Okay, cool. Well, then let's tentatively aim for that. Lots of support in the chat. Thank you, everybody. Yeah, cool. All right. Well, then everybody keep an eye out. We'll post something in the Discord as to specifically when the next stream is. And thank everybody for joining. And until next time.
Till next time.
Thanks, everybody.
All right.
Bye, everyone.